Well, hello everybody. Good day to you guys. Welcome back to the channel. I'm climbing in this morning to this 2008 Chevrolet. It's a Silverado 2500 HD crew cab long bed with a 6.6 Duramax and an Allison 6-speed transmission. This thing has some weird electrical problems, and we're going to get to the root of that very quickly. I want to talk about modifications and, more importantly, emission system deletes. This is a deleted truck. It's got something of a turbo on it. Sounds kind of pretty good. I've had an intermittent check engine light and reduced power failure on this truck. I've been kind of battling this thing for a few days now, and it's definitely giving me a hard time. This is one of them situations where every time we fix something, we find something else that is wrong or something else has been breaking. We're at a point now where it's blowing up a fuse for the mass airflow sensor, which normally is causing a check engine light, which I think is off at the moment. We threw a fuse in it yesterday and it has not come back on just yet, but we're gonna go figure out why that fuse keeps opening up. I think it has something to do with the shoddy work that whoever deleted the emission system on this was responsible for, and I believe we have a wiring harness problem. So let's get it into the shop and we're gonna take a look at the carnage that some other technician caused when they were trying to do a performance improvement on this particular Duramax. See, there's kind of a right way to do things and a wrong way, and I think this one was done the wrong way. Now, I realize we're doing some work on an emissions deleted truck. Federal law prohibits an individual from removing, canceling, deleting, or disabling any emissions control devices on a vehicle. Now, I'm not responsible for this. The guy that owns it's not responsible for this. He just bought this thing. So I don't know who did the delete on it. I'm not gonna rat them out even if I found out who did it, because I'm not one to narc on people. Power down. And I'm not a cop, so I'm not doing that job for anybody, including the feds. Not my problem. But I am gonna fix the truck and make the thing work again if I can. So let us get started. Now, why on earth would somebody take parts on their truck that came with it and remove them? See, there's myth and there's a little bit of fact when it comes to deleted vehicles. You see, the myth is that emissions equipment on an engine will rob you of performance, will rob you of efficiency, and reduce engine longevity. That's the myth section of why we have emissions equipment. And yes, there is some truth to that, but it's not as exaggerated as people like to say. For example, a catalytic converter. You're gonna find these on all gasoline engines, and it's basically just a filter coated with precious metals, and when those precious metals encounter hydrocarbons, a chemical reaction takes place and it changes those hydrocarbons, fuel, into a less toxic emitted gas, therefore it pollutes less. So I'm not in the camp of catalytic converters are all horrible. They do not produce as much restriction in the exhaust flow as people think they do, and consequently they're not robbing horsepower the way that people think they do. Now, on the other side of the coin, you can take a diesel engine with its EGR system. That's the exhaust gas recirculation system. What the EGR does is basically takes exhaust gases and then pumps them back into the intake and lets the engine reburn them for a second time. Okay, that's part of reducing the tailpipe emissions and reducing certain types of chemicals in those tailpipes. Now, the drawback to that is the engine is breathing its own waste product. So that can't be good in any measurable metric. So what happens on most diesel engines is after some time, a bunch of carbon and other contaminants will build up and effectively clog the intake system of the engine. Now, diesels, modern diesels, they're kind of getting the shaft from two different directions. So we've got regurgitating waste on our intake side, and then on most modern diesels they have an emissions filter in the exhaust. So imagine you take this and multiply that by 100 times and then shove it up under the truck. You're going to turn the entire bottom section of this truck into a gigantic exhaust filter. What that filter is supposed to do is collect the soot and particulate matter from the engine. It collects it in that filter. Then when that filter becomes full, the engine will go into a rich burn condition, so it's basically dumping fuel through it. It's gonna burn that fuel up in the exhaust, and it's gonna cook off all of that built up soot and then just send it out of the tailpipe. So we're gonna store it for a while, throw some fuel into it once we're full, and then we're gonna burn it all off and send it out anyway. Now, the advantage of that is you don't get to witness any black smoke and soot out of a diesel engine when it's under load. Okay, you don't get to see it, so the perception of polluting is no longer there. We're still polluting, but we're just doing it a little bit differently. We're kind of outsourcing it and kicking that can down the road a little bit, but it still occurs. Keep that in mind, because the real drawback on some of these emissions equipped vehicles is the cost that the purchaser, the end user, must incur to buy the vehicle. See, the federal government says that these vehicles have to have this equipment on there for sale in the United States. Now, some of these vehicles that are shipped overseas, they are factory deleted and they're not equipped with emissions equipment. That's a whole different type of video and different story. I digress. So the end user, they've got to pay a premium for those components. For example, the exhaust filter for this truck, which is a 6-7 foot long piece full of filter material, that's going to cost northward of $3,000-$4,000, not even counting the sensors that are required, up to 5 or 6 sensors per exhaust system per vehicle. You've got multiple modules that are designed to sense nitrides of oxygen, NOx, CO2, oxygen, hydrocarbons, you name it, those sensors are there. And there's also temperature and pressure sensors on that exhaust. And that's what the ECM uses to determine the fullness of the filter. So it's a very highly complicated system, and it's very failure prone. Now the problem with that is let's say you've got a 40-foot long gooseneck trailer on this thing, and you're out in the middle of Colorado. Well, all of a sudden your truck decides it's not going to do a regen procedure and it's not going to clean out that filter. So the ECM will put your truck into reduced power mode, which means you have no horsepower. You have just enough power left to go ahead and pull off the highway and park it and then get it towed for service. And that's a major problem when we're factoring in economic losses and cost of ownership. Now, the federal government has since rolled back the restrictions on what vehicles are allowed to do once they've reached a regen potential and it cannot regenerate. So what they have allowed now is that the engines will not enter a limp mode reduced power in order to prevent people from being stranded on the side of the highway because they've had an emission system failure. One more example, let's say one of those sensors goes out on that emission system, the entire system will no longer function. It'll just sit there and collect soot and collect soot and collect soot until ultimately it chokes the engine to death. And that results in costing you valuable time and money as the end user for a product that you really didn't want. If you can't tell, I'm biasing a little bit on one side, not too far, but I do have a rub against the way we legislate these rules, okay? So when it comes to my opinion, I am not a fan of EGR systems because they do pump the engine's waste back into its intake stream. That's never a good thing. I'm not exactly a fan of the exhaust filter because we're just outsourcing the pollution to a later time and date. It's not happening on the city streets, it happens when we get on the highway. So we're not really saving the environment by capturing the soot. Utilizing an EGR helps to control the combustion temperatures inside of the engine, so it keeps those exhaust gas temperatures down because we're reducing the amount of available oxygen. Yes, that does give you a reduction in horsepower. However, when the EGR is actuated, it is not under normally a full throttle condition. Those are mid throttle condition operations, and therefore you're not asking for full horsepower, so your loss in power by using EGR is negligible, and you'll never notice it as the driver because you're not asking for output at the time the EGR is working. So in my estimation, the only real drawback is the way that the EGR will pollute the engine internally, which does subtract away from longevity. Now, what we get into when it comes to this truck is this truck has been deleted. It's had a turbo installed on it, some kind of performance turbo. I can tell by this vane actuator device right here. This is to kind of modify the signals between ECM and the vane position on the turbo. That way the ECM can recognize this different type of turbo. I'm not exactly sure the nature and specific purpose of these, but I do know that these aftermarket turbos do come with this little module. Anyway, I digress. Coming over here to this other side, this is where the delete has taken place. The EGR cooler is supposed to be in this area here underneath this tubing, and that cooler is missing. The other thing that is missing on this vehicle is the entire emissions exhaust system. There's no filter, no converters, none of that. It's just pipes and a muffler, okay? Now this is a telltale sign of a deleted truck. We've got all the connectors hanging down, disconnected, just sitting around all willy-nilly like, right? We've got another one back here. That's our pressure, differential pressure sensor right there. This one measures the pressures from one side of the exhaust filter, and it measures pressure on the other side of the exhaust filter, and it compares the difference of those two values to determine how full that filter is. Okay, so we've got wires dangling down there, and this might only be like a 3 or 4 wire truck because it's an older one. There should be 2 more dangling wires somewhere near the firewall for some NOx sensors, which have also been removed. So when we delete these things, it gets a little sloppy looking because we're using some aftermarket parts. That looks gross. It's making noise. That's busted off or cut off and not reinstalled. You see, it's a sloppy delete at best, okay? When we get to the engine compartment, that's where we're really starting to see the show. Let me climb over here. So over here under the hood, since we've disconnected a bunch of stuff, we have wires and pigtails and harnesses just sitting around all willy-nilly like. You know, there's no more wire loom left over. And we have cut wires and spliced wires and stuff run everywhere. So the guy that did the work on this to remove all those emissions parts for more horsepower, they pretty much sealed the fate of this truck and caused it to be inoperable, because as time did its thing, one of these wires, and I believe it's this pink one right here, that pink wire has an intermittent short to ground because this wiring harness condition is absolutely horrendous. And I know that because under the fuse block here, this truck keeps blowing up this fuse right here. That's a 15 amp fuse. If we look over at the ledger, what position is that? That's gonna be, I think position number 6, number 3, yep. Engine 15 amp, fuse position number 3. I hope you guys can see that. So this fuse right here powers the power wire running over here to this mass airflow sensor. Okay, this is that's 12 volt, low amperage. This wire right here continues to blow up that fuse. So I believe that between this connector and this fuse, something is shorting to ground somewhere in here, causing this engine to lose the mass airflow sensor. And if the ECM doesn't know how much air is coming in, it does not know what to do, and it goes into a reduced power mode. So effectively, we have created the condition that all this time and money was spent trying to remedy because we did a botched repair at best. Yeah, this is not supposed to be this sloppy right here. So I want to go ahead and pull out some wiring diagrams and see if we cannot figure out what the deal is with this thing shorting out, blowing up that fuse, and then shutting down the truck. Loud noises. So real quick, let me show you. We start the engine, runs normally, all seems well, right? Now let's simulate blowing up that fuse. Fuse is blown up. So now the mass airflow sensor should be seeing nothing. There's our check engine light, reduced engine power, right? So that's what it's been narrowed down to, is we're losing that fuse. I had done some other work on this earlier. This is kind of a comeback because we had replaced an ECM for a 5 volt reference failure. It was losing 5 volt reference to multiple critical sensors. One was the fuel pressure sensor on the fuel rail. The other was engine oil pressure. The other was the DPFE sensor back on the exhaust. We saw that earlier. And I believe, I think one of the AC system pressure sensors was also on that 5-volt reference fuse. So we had previously, once upon a time, replaced this ECM with a used unit, which was also super fun because this thing has a tune on it to accommodate the missing components. See, when you delete things off of your vehicle, you've got to tell the ECM that those are no longer there. If the ECM tries to run EGR or tries to do a regen and there is no EGR, you're going to get a check engine light and you're going to get reduced power. So they had to install a tune on the ECM to remove those items from the ECM so it would not be looking for them and the engine would run normally. Well, when I had to replace that ECM, we had to buy another one. I had to send the new old one out with the faulty unit. They had to take the program off the faulty unit, effectively jailbreak the thing, steal the program out of it, and then force feed it into another ECM, and then we plugged that thing in and now here we are. So it was a fiasco at best just to replace a component because this is a deleted truck. So right, now I find myself here today at the tail end of a series of bad decisions, and I've got this beautiful example of craftsmanship to work with, trying to find a short in an electrical connector in a wire somewhere. And folks have been everywhere through this thing. So I really don't know kind of where to begin. Okay, so I threw a scan tool on the truck. I got this new one over here. It's not the snap-on, but it's got a little wireless thing so I can work from far away, which is great. We've got a P0102. Now, I did cause this code, mass airflow, circuit low frequency. It's not reading anything. I caused it because we disconnected the fuse. Now, that fuse has been replaced with a new one because it does blow up. So, this is the appropriate code. Now, over here on our wiring diagrams, I've got the engine control diagrams pulled up. So what we're looking at on the left, this is all ECM, and then all of these other little devices, these are the sensors attached to said ECM, okay? So we've got sensors, sensors, all this stuff is sensors, right? Down here at the bottom, we've got our mass airflow sensor. Now that's actually two sensors in one. You've got the mass airflow, that's one element. And then you've got the intake air temperature, IAT. See that right there? So there's two circuits for the temperature, these two tan wires. And then there's three circuits for the mass airflow. A ground, a power, and then a return to the ECM to let us know what the sensor's doing. Now, the fuse that's blowing, that's off this pink line right here, which I've highlighted in yellow. We're gonna follow it along to the next page. You know, once upon a time, we used to have to print these pages all and then fold the edges over and then tape them together to make one big page. Technology's come a long way. Anyway, that leads us right back, if we follow our highlighted line, leads us right over here to the under hood fuse block. That's that fuse box we were just messing with. And fuse ENG, that's engine fuse number 3, 15 amp, that's the one that supplies power directly to our mass airflow, okay? Now, this vehicle has a good quality replacement mass airflow sensor in there, okay? That's a Hitachi. I believe that's the same manufacturer. This has been replaced. I think the customer put this thing in after the fuse blew up, after we put an ECM in it. So our pink wire right here goes into this harness, gets wrapped over this harness, gets shoved back down under here, and then it looks like, let's see, that's a coolant temp sensor there, alternator field control. Maybe it goes the other way. Anyway, this pink wire eventually ends up over here to get power from this fuse box. So between here and there, that's where our problem is. I'm gonna go ahead and power down and shut off our charger. I had the key on for a while, and this thing has an aftermarket fuel pump down below. The fuel pump draws some current, and I didn't want to run the batteries dead. Never good to run your batteries dead. So we have some more aftermarket rigmarole right here. This is a power tap wire. it's a add a circuit little device here. This allows us to pull some power out of the fuse block and then send it somewhere else. I believe this goes to the relay, which turns on the fuel pump down below. That's how my truck is configured. That right there should be the relay, I think. Regardless, we're just going to disconnect that. These fuse boxes, GM was very considerate with these. They gave us these little flappy things here so we can remove our fuse blocks. This one's very full of dirt. We need to disconnect the power cables from it. We're going to wiggle this thing out. Yeah, that's jammed in there good. See all this impacted dirt and dirt dauber nests and creatures? Ugh, nasty. All that stuff is inside these nooks and crannies, taking up space. Our problem could be right here in the fuse box. Let's go ahead and fetch a socket. We need a 10 and a 13 because somebody replaced the 13 with another 10. We're gonna take this off right here, get rid of these two power wires, and then manhandle this thing out of the fuse box tray. Do not break off. Get out of here. If I break this off, we're up a major creek. Yeah, that's gonna break off. That's fantastic. I'm gonna utilize inertia. No, I'm not. Oh, that's complicating things a little bit. Okay, so I'm gonna try to pull this out without taking the power wires off, or I've got to cut them. Ooh. I don't think I'm gonna get this fuse box to come free. Ooh, there we go. Yeah, this thing's super impacted with crap. What's all that noise you're making over there? Slamming the doors? Okay, I've got, I know you guys can't really see that well, sorry. This harness is stuck in here. It should have stayed in there. Just to pry it out with a screwdriver or something. A little close up. See, that guy's stuck. It should have popped right out, but it is not. Creatures living in here. Okay. Crustomatic. Okay. Spider web thing. Get rid of you. Gross. This can go back down in its position right down there. That stays there. Okay. I think this is our connector in question. If we look at the location, and this is not always, doesn't always correlate, but that's where our fuse is supposed to go. So it stands to reason that one of these right here in this area is the pin. Now, I said those don't always correlate because sometimes they can run a bus bar through here, and if the fuse is here, for example, the output might be, over here. You don't know. So you've got to double check. Once we find the pin that corresponds to that fuse, then we'll know which pin on the connectors is the corresponding connector. Then we can go over to the mass airflow sensor and we can do a resistance reading on that that circuit to see if it's got a resistance problem. And if not, then I'll try to run a new wire and go from there. Okay. Setting up our multimeter here. We've got a ground connection made to ground with a jumper cable. We're set to continuity with the alarm. So when these two guys touch each other, we're gonna get that alarm. It's gonna give us a resistance value. See that? Good contact. So what we'll do is we'll take our positive in and we're gonna poke that into our little fuse connector there, right? Disconnecting the meter from ground. I think this is the power side. See how we're, yeah, that's the power side of the bus bar. So where we should be testing is gonna be in this pin right here. That's our output side. It doesn't feel that great. See that? No continuity over here. Okay, so this wire right here, we need to figure out which pin on the back side that one's connected to. I did not find that first on purpose. Why is there two? That pin and that pin. That makes no sense. There should only be one, but that's okay. Let's check. Let's check our actual connector. Maybe there's not two wires connecting to it. So we're gonna be 1, 2, 3, 4 slots over, 1, 2, 3, 4 slots over, and 1 slot up. That one's blank. This one right here should match up with this one right here. So that's our test pin right there, okay? So what we're gonna do, take that back out. We'll put the probe in that little connector right there, see that? And we should get a positive reading at that connector over there for continuity. And when we do that, we're gonna get our resistance value on that circuit. So, take our lead, come on over here, set you guys down, bear with me. The pink wire is the center. Let's see here. That one there. There it is. Okay, so we found the correct wire, right? And we have good resistance. Okay. Did I catch it in the act? Bad connection. Ooh. There we go. Okay, so we have connection. Good connection, okay? We're doing what's called the wiggle test. I'm gonna move this harness around, and we're looking for this thing to go open circuit or short to ground. No. No. Nada. Okay. Let's do some isolating next. Bear with the beep. I'm going to disconnect these two primary ECM connectors. We're going to figure out which one, not this one, which one has our suspected wire in the harness. Maybe this one here. No. Okay, so this harness does not run through these two connectors. That's great. Okay. We'll shut you off. That's annoying. So there's enough exposed wire here. Maybe we can start tracing this and figure out where it goes. So this harness runs right into here, and it's pointing this way. I see no pink wires going that way. So our harness issue is in here somewhere. It's this one. It's got to be this one right here. Booyah. Oh, no way, I found it. Sweet. Hang on, I think I found it. That might be our winner right there. Let's cut some zip ties out of here. Get some working space a little bit. We can always put more zip ties back, right? Just keep adding cable ties. Disconnect that thing. Of course, I can't move the harness anywhere to really get into it, but that's fine. I see a wire. Yeah, let's cut this open some. We can always put more tape back on it, right? Yep. Climbing in. I'm sitting on top of the radiator right now. Oh yeah. Okay, so what do we have here? We've got a green wire. I see copper. There's a pink wire right there. And we've got this orange with the black tracer. Okay, so here's what we're gonna do. I'm gonna prove that that's the one. That's the wire shorting me to ground, right? What we're gonna do is reconnect this meter to ground. We're gonna reprobe this wire right here on our positive side. Then we're gonna take this wire and we're gonna simulate driving conditions, right? See all that rubbing? This thing vibrating with that thing being held on with the zip tie right there. It vibrated through the wire harness, through the tape, and then through the insulation. I think that is our short to ground right there. So let's prove it. Okay, here's our recreated electrical short. I've got a ground to battery ground, grounded to the meter, positive lead, probing into our mass airflow connector, wiring harness. Let's rub it. Look at that. Look at that right there. That's our short to ground blowing up the fuse. Intermittent vibration, making this thing make contact with that line. That line's grounded to this compressor, which is grounded ultimately to that battery. That's our fault right there. Shoddy work. Found it. So going back to where this kind of video started from, I kind of do blame the concept of deleting this truck on this failure. It did take a bit of time, and it took some poor quality work at best to cause this. I wish some more diligence had been taken during this this original repair a long time ago when they put the turbo on and did the delete. This could have been done way better. This should have been protected, and it should not have been zip tied like so. That just didn't need to be that way. So if you're gonna buy one of these trucks and you don't know about deleted vehicles and the complications that can arise from them, think twice about it. I know we all say we want things like more horsepower and, you know, no, we don't want that emissions crap on my truck. Well, you know, you take it off and you're gonna run into some problems. Additionally, if you've got a truck and you try to trade that in and you've had it deleted, the dealership is not lawfully allowed to process that vehicle. They cannot sell a vehicle that has emissions equipment removed. So if you delete your truck and then try to sell it, you may have a hard time trading it in. You can sell it to a private buyer, but the dealership will not accept that vehicle on trade. And if they do, they're gonna be calling you back later on when they find out it's been deleted, and they're gonna have to undo the deal, and they will do that to you. It's a guarantee they will, because they're not gonna lose money on your trade-in because there were parts taken off, I assure you. Anyway, I digress. Let's just go ahead and tape this up and call it good, sticking with the theme of the truck, and I think that's a win for the day, right? What do you guys say? Nah, I'm just kidding, you guys. We're gonna fix it. I've got a whole set of wire nuts hanging out. Oh, you know what? I want to check what these other two wires are doing in here, because I did put an ECM in this for a short to ground on a 5-volt reference circuit. So we've got a green, not the pink. We know that that's not on the 5-volt ref, but there's the green and a looks like a tan and black. Let's check the diagram one more time just to make sure I didn't sell this guy an ECM for no reason. We had a P0562, I think was the last code. 5-volt ref number 1, short to ground is loud noises. So let's check those wires that correspond to that code and make sure that those wires are not part of the problem. All right, back at the digigram, and I misspoke just now. It's 5-volt ref 2. There's 1, 2, and 3 different 5-volt reference circuits on this this setup here. We were dealing with 5-volt ref 2, which was engine oil pressure, DPFE. Yep, we talked about those sensors earlier. And there should be another one in here for the AC. I only see the 2. Okay, well, looking at our ECM, 5-volt ref 2, tan wire, 5-volt ref 2, tan wire. Okay, going down. Oh, did not mean to highlight all of those. Scheisse. And the other one, there's another 5-volt ref. Yeah, tan and tan. I thought I saw 3 or 4 of them here. Oh, there we go. We got a gray 5-volt ref. That's 1. 5-volt ref 2, that's gray, and that is gray. So all of the 5-volt ref pins on circuit 2 on the ECM are tan solid and gray solid. That's good. I feel better about my life now. Because the wires that are also damaged over here, there is no gray. I've got no solid gray. I've got a green, like a light green, like a puke green, and then a tan with a black tracer, but none of those 5-volt refs on the diagram have a black tracer. So I am confident that my ECM repair was accurate, and I'm also confident now that I found the short. And it only looks like, out of these 3 wires, it only looks like that that pink wire has rubbed through. The other 2 have some damage on them, but it's just the pink that is exposed. These other 2 do not show any copper. This one, that green one there, may have a sliver. I can't really tell. But we're gonna do a splice repair on this pink one here, and then we're gonna seal up the others with some tape, I think, and that should, that's gonna conclude this one. Yeah, let's go ahead and make this fixed real fast. Okay, let's try to zoom this in a little bit with my camera here so you can see closer. It's ready for its close-up. What we're gonna do is we're gonna cut this right at the damaged section, right there. Cut away that. There we go. Now we can make a decent repair in there. We're just gonna do a heat shrink splice. Strip some wire back. The reason I'm doing a splice and not a solder is because I don't want to add more wire to this when we can just use what we've got. See that? This little barrel crimp connector. Feed it in. What are they listening to next door?
I don't know.
Some polka polka?
Yeah. Mexican polka.
You can't call it Mexican, that's racist. Actually, yeah, they're getting down with it over there, man.
I'm not gonna lie.
Kind of sounds like Dearborn. There we go. I'm not going to repeat it. Get myself canceled. Yeah. Get a good twist in that. Oh no, I don't have enough wire. Yeah, I don't have enough. Well, maybe. I mean, what do you think? It reaches. No room for a service loop, I can tell you that. It's gonna reach. I think we're gonna go with it. Now, I'm gonna have to add a piece of wire in there. We can't use that. It's gonna vibrate and it'll pull this out of that connector. And then we'll be right back where we started from. So I'm gonna add a little piece of wire in there just to extend that a little bit, and 2 splices. Okay, so here's a new piece of wire here. We're just gonna strip that guy back. I always keep wire and stuff sitting around for these types of dealios. Oh, you can't see. There, now you can see. That one in there. We'll give it a crimp so it stays naturally. And because spec says just do 1 crimp, we're going to do 2 because that means it's twice as good. There we go. This side here, let's cut it off. There's good. Fail. Horrible fail. Dang. Pulled that thing right out. I have to fold, I'm gonna have to fold it over to make the wire thicker to fit inside of the crimps. These are small crimps too. I'll just take it, fold it around, double it down on itself. And if it fits in the barrel, you got a winner. If not, we'll have to up this to the red one, the larger size. Going in? Nope. Okay, we're gonna make the splice first. Easier to work with up here. Man. There we go. Okay, redo. So I've cut the wire piece. Stick that guy in. Crimp the daylights out of it. That's good. Okay. One more. Second crimp, smash. There we go. So now we've got our little splice bridge thing. So we'll come down under here. Feed that guy in. Little frayed piece there. Let's just give it a happy little twist. It's a happy accident. Little happy twist there. Yes. Go in. There we go. Oh, don't come out. Stay there. Okay. Around the other side here. Give that wire some twist. The hole in this connector is super tiny. There we go. Hope you guys can see that's in. One crimp. I think we're in good shape here. All right. Okay, a little bit of fuego here for the heat shrink part of the heat shrink. Yeah, I know, the lighter's dirty. Could have used a heat gun, but I didn't. Just gonna use a lighter. It works, it's highly effective. Makes some soot though, see the soot? Preferable, or not preferable over the heat gun, but it's just two wires, we're fine. There we go. Prepared, hot. So now we'll take that, kind of, what I want to do, put our service loop down here, keep those connectors straight as possible. So the excess will just hang out like that. There we go. Like so. Okay, let's get some tape. Okay, electron tape coming in. We want to secure those crimps to the rest of the wires so they can't vibrate. Send this thing back this way. Second crimp is being taped down, that's nice and flat. And if this harness ever gets tugged on, it won't stress out the repaired circuit, it'll put stress on the other circuits, which they have not been repaired, so those are fine. There we go. Now I'm not going to zip tie that back up and let it rub through again. We're just going to let it sit there all willy-nilly like, and it can vibrate. Down here. I will tape or zip tie this device to the harness, And I should probably get around to putting this other stuff back together. What do you guys say? What are we stuck on? Oh, we have wires zip tied to the connectors too. Good job, everyone. And I don't mean that genuinely. What is this? Is this connector broken? Yeah. Of course the main wiring harness connector is broken. Why wouldn't it be? There. Woohoo. Okay, so now let's get some air, blow this fuse box out, get rid of all this nasty on here, put the fuse block back on, put the fuse back in it, fire it back on. Okay, loud noises incoming. Got some air here. Air pressure. Nice. Kind of nice. Okay. I'm gonna come around and set this box back down in position. We've got to have this thing in the up position like so to get it started. Watch closely. See if we figure it out. Nope, can't figure it out. It's the hammering. I'm being distracted by the hammers. No, it's just my brain can't. You're apologizing for working? Don't do that. There we go. And a little fuse, I lost it. I just saw it a second ago. It's fine, I get another. Turn one 15 ampere blue in color fuse right there on ECM3. So, fuse box is back, that's plugged in. Let's plug the mass airflow back in. Clicks. All right, so now let's hop inside, clear the code, fire it up, and it should be working as designed. Is it gonna work? What do you guys think? Did we win? Yeah. And we're out of reduced engine power. Second restart. 187. The theme is fitting. All right, we got a winner here. But the turbo does sound absolutely wonderful. Love the turbine sound. So I think we've got a fix here. That's a confirmed kill on a shorted wire. That reaffirms my first position on this when we put an ECM in it once upon a time. I'm super glad that I didn't have to put foot in mouth and refund an ECM. So that's kind of cool on my end. Not great for the customer, but it's good for me. But his truck has been fixed. It's been a long, arduous road, and that I think was the last of it. So let me know what you guys think about this repair and procedure and this truck in general in the comment section down below. What do you think about deletes on vehicles? Would you consider deleting yours, or just leave it alone and not deal with the hassle? Let me know about that also in the comment section down below. While you're down there, don't forget to like this video to let me and YouTube know that you enjoyed the content created. If you do enjoy the content, check your subscription status and also check your notification bell. If your bell is turned off when I post a video, you will not receive a notification from YouTube. If you turn the bell on, Well, you probably won't receive a notification from YouTube anyway, because YouTube doesn't send out notifications like they used to, but it's worth a shot. So you guys check your subscribe status, turn that bell on, give me a like button if you would. And most importantly, before I go, I'd like to wish every one of you guys a fantastic day. I hope you have a great weekend, and I will see you guys in the next one. Thanks for watching. Have a great day, in a video, in a GMC / Chevrolet, whatever, in a transmission.